Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab, and we're sort of going to continue our exploration into electronics. And today though I'm going to have a little different approach, because we've been working on this setup. You've seen it before. This is the buoy board that's powering these LED lights, and you can see I've made a sort of an adjustment to this now, and that was a bit of fun really, because if you remember, this required more volts than the buoy board is normally supplied with, because we normally supply it with 5 volts, and to have a 5 volt rail and then a 20 or 30 volt rail to power this LED ring that's normally found in a light enclosure was a bit of a pain. So as an experiment, I got this boost converter board for a couple of quid on eBay, and you can see it's parasitically drawing its power from the main circuit that the buoy board relies on, and then it's boosting up the voltage to the 20 volts for the LED. But of course this is quite an inefficient way of doing it, and you're going to sort of draw quite a lot of current through the whole circuit to get this going. But it does work, and I'll show you while we're here. So I'm just going to turn my bench power supply onto 5 volts. But as I said, this video is not about this setup. That we'll cover elsewhere. But look, there you go, and that's the LED's briefly flashing there, and that's the buoy board, of course, changing the colours. And it's not doing a particularly interesting one. We've got the blue going off, and then the green and the red coming on at the same time. So it's not a particularly great pattern, but that's where we got up to, if you recall, in our code. But I'm going to put this aside, because the progression to getting to sort of here and doing this board and more advanced boards, as you'll see as the this little series progresses, I didn't just stop here. I kind of kept going until I got distracted in other business avenues. It had to start somewhere else, and I was having a little bit of a clear out, and I found a number of items that I thought you might get a kick out of seeing, and I'll kind of, let's try to work out what they were doing basically. So here, now I remember this one. This is one of my, oh gosh, look, I've just broken something. This is one of the sort of first sort of items I made, which would have been around, I'm gonna guess, about 14-15 years ago, maybe playing around with automotive projects. That's when I started automotive projects. And this one, believe it or not, is a rev counter. And we're just going to, it was all hooked up to a car, and then it would give you, the revs, 2000 RPM. And this is what this does. And I don't have the code or anything like that for it. And I can't even remember if I'd have written it in assembler or, C. But let's have a look at the actual main components here. So here you've got the microcontroller, and just sort of turning it in the light, I can see it's a PIC 16F84A. So just a small little general purpose microcontroller. I'm just having a look. Excellent. I'm going to show you something in a moment. This is an LM7805. So this would have been the power regulation, because of course it's being driven from the automotive 12 volt system. So we need to get our 5 volts for our whole PIC and LEDs and stuff to be driven off. So that's what's going on there. There's a resistor there. I'm not sure what that's going on. I think this might have just been a signal input from the actual it would have been on the coil of the vehicle, so it would have been detecting that coil fluctuating to give us our revs. But if I turn over on the back, you can see this very interesting sort of 3-dimensional wiring here. But there, underneath all of that, is a resistor and a capacitor, and that's the timing circuit. So that's effectively our oscillator that powers the whole thing. I don't know what the frequency would have been. It could be quite fun. We could actually try to power this up. I'm thinking we shall try to power this up, shall we? We could put a scope on that to see what frequency it runs at. Maybe that's a bit too far today to bother going with, but why don't we try powering it up? And I'm going to set my meter to about 7 volts, because I don't want to overdrive it. And looking here, I've got two black wires and a red, so I kind of have a good idea which might be the positive, but the negative? I don't know. So we've got, there's definitely hooked to different parts of the circuitry here, but I think this might be a potential divider coming in off the actual coil input. So I think these two here might be the actual power rails, but God, why don't we just hook something up and try it, really? So I can see the red is going to here and then jumpering across to there, so I could get the positive hooked onto this bit of the variable. That should work. And the black is following up that white wire through. I'll just turn the power supply off while I analyse this circuit. Looks to be going right here. So it's probably upside down. But let's have a go, shall we? Not seeing a great deal of activity. Okay, that's fine. Let's try the... Just one more go, shall we? Just one more go and then we'll call it quits. So we'll hook that on there. God, it's so fiddly. Sometimes, you know, you might want to just let sleeping dogs lie. Turn the power on, but then I'm just going to have it loose and see if I can just do it by hand. No, that didn't do it either, so sad. But yeah, it's kind of cool. If you see how it's sort of wired up to this pick, I'm just going to have a little guess. 7-segment stuff is really fun. I've got boxes of those, so you're bound to start seeing those on my web store, really. So I want to get shift off some of those. But yeah, they're kind of like this. And remember, they're just sort of LEDs. But I can't remember how they're basically wired up, but I'm going to just give a guess. So imagine you've got a load of LEDs like this, and I can't remember if the cathode or the anode are actually wired up. Common, so something will be like that basically. And then the idea is on your microcontroller, if you want to keep the brightness even Stevens, you should have a bunch of resistors in there. But you can see I haven't got one resistor among any of that because I'm doing a little bit of a trick. I'm sort of running them very quickly, like pulsing them, so they never really draw any current. But yeah, this would basically then just go into your microcontroller. So if you imagine internally it's got a transistor, but I'm just going to draw it as a little switch like that. That's what it's acting as. So there we go. In fact, you'd normally sync the current rather than source it for LEDs because they've got a higher syncing rate. But anyway, imagine that. So what happens is if you want to get an 8, so imagine these are the sections here, like A, B, C, D, E, F, and G. Let's do a 0 because an 8's pretty much all of them. If this is A, B, C, D, E, F, and there's a G here, we'll just add a little G. Okay. If you want to get this to say 0, which you can imagine looks like that, that's your close. You basically want A, B, D, E, G, and F. And that's exactly what you do. A, B, D, I lost count, E, F, and G. And then that would just be a 0. And that's all it works. The code is just twiddling these in terms of switches, and that's getting your digit. And all you're doing, now you'll basically imagine all of this is contained now in one block, so that's one of those panels, and then you've got another 4 of these, right? So I'm just going to draw them like this. So imagine they're all like this, yeah? All of their A, B, C, D, E, F, G wires are all basically joined together. So imagine all the A's joined together, all the B's on this side, and then the common bit on this side, instead of just being hooked up to sort of ground, they're actually, well, or positive if it's syncing, they're actually hooked up to other pins, another 4 pins on the microcontroller, right? So what the micro does is say, switch this one, and I want this pattern. So it'll switch the pattern basically, and then normally switch to that to make that's an 8. And then it'll quickly flick to that one, and put that one as like, you know, the 2, quickly that one 0, and then quickly that one 1, and it'll just do it very quick like that. But because of your persistence of vision, it'll all look like the numbers are nice and stable. That's sometimes though why I think you see the LEDs on the back of cars and they have that kind of strobing effect because of that. It's running at a particular frequency and it's sort of basically strobing. But the faster you can run your device, basically you'll stop seeing that. It'll be so fast. You know, imagine it's like, I don't know, 50 hertz, 100 hertz, I think then you'll really not be able to see it. And that's what that is. But this isn't the last of my objects. This is merely the first. I've got another couple to do, but I'm going to save them for the next video because we're going to go through those equally in as much detail. But I hope you've enjoyed this little walk down memory lane, and had a look at my very first rev counter design. Look at that cutie, huh? Look at it. It's gorgeous. I'm going to keep that not in the shelf of curiosity, but my special container of special projects. But yeah, thank you so much for joining me, and we'll be covering more of my special project in future videos. As ever, thanks for watching.